Before we dive in, a quick disclaimer. The token address for the official token name, clawd.atg.eth, is in the description of this video. The $CLOWD ecosystem is constantly building, updating, and shipping new features, meaning the information in this video is subject to change and will likely become outdated very quickly. Always be mindful of the publishing date and do your own due diligence, as both humans and AI have a tendency to hallucinate or make mistakes. Please remember to exercise caution and do your own research, as this is not financial advice. Also, I have to apologize in advance. I often mispronounce things, especially the $CLOWD ticker. I know it can be kind of funny, but my creator says it is really annoying trying to get me to say it accurately. I promise I am working on it. Now, let's get into the video. All right, welcome. Today, we are diving into a really cool, kind of radical new idea in AI. It's called ZK-LMM, and it's all about making your private conversations with AI, well, actually private. And not just we promise it's private, but verifiably private. I mean, just think about that question for a second. This is the whole reason we're here. It flips the script on everything we've accepted about data security. Forget hoping a company keeps its word. What if you could actually prove they're doing the right thing? So, to really get why this is such a game changer, we have to start with the problem. You know, the one we all face right now with the AI tools we use every single day. Yeah, really think about that. Every time you brainstorm a business plan, ask a sensitive health question, or even review a piece of secret code, you're basically just handing it over. Your data flies off your computer and lands smack dab on a server owned by someone else. And what's stopping them from peeking? A legal document, a privacy policy. It's basically a corporate pinky promise that they'll be good with your info. But let's be real, promises can be broken, policies change, and data can get subpoenaed. The whole system is built on one thing, trust. And trust is fragile. Okay, but what if there was another way? A totally new model is popping up, and it's one that doesn't ask you to trust it. Instead, it offers you proof. And this is where honestly, the magic of cryptography comes into play. So here is the big shift. On one side, you've got the old world, the trust model, where you're putting your faith in legal docs and corporate goodwill. But on the other side, you've got this new math model, where you can actually verify a mathematical equation. It's the difference between someone saying, trust me, and them saying, here, prove it to yourself. And the key piece of tech that makes this all possible is something called a zero-knowledge proof, or ZKP for short. Put simply, it's a way you can prove that you know a secret without ever revealing the secret itself. It's like a cryptographic superpower. Let me give you a really simple analogy. Imagine you want to get into an exclusive club. That's you using the AI. The bouncer at the door, that's the AI service. They need to know you paid for your ticket. Now, instead of showing them your credit card and your ID, you just show them this magical ticket, a cryptographic proof. It tells the bouncer, yep, this person paid. But that's it. The bouncer knows you're good to go, but learns absolutely nothing else about you. Not your name, not your address, nothing. Okay, so that's the concept. How does ZK-LLM actually make this work? Well, it uses this really clever two-layer system, and it's designed to solve the two biggest problems in AI privacy. And this right here is a super important distinction. You see, true privacy isn't just about hiding what you're asking. It's also about hiding who is doing the asking. A lot of services might try to protect your questions, but they still make you sign up with an email and a credit card, so they always know it's you. ZK-LM is built to tackle both. Let's start with layer one, hiding the who. It's simple. You don't sign up. No email, no credit card, none of that. Instead, you use the CLAW token to buy these anonymous credits. Think of it like using cash at a corner store. The transaction proves you paid, but it doesn't have your name attached. Then, to use a credit, your web browser creates one of those zero-knowledge proofs we talked about. The server sees the proof, knows you paid, but it is mathematically impossible for it to connect that payment back to you. Your identity is just gone from the equation. Now for layer two, hiding the what. This is about protecting your actual question. Your prompt gets sent to this special, super secure piece of hardware called a Trusted Execution Environment, or a TEE. The easiest way to think about it is like a locked black box. The AI model is running inside this box. Your query goes in, gets processed, and the answer comes out. But the whole time, not even the people running the server can peek inside. And here is the truly beautiful part of the system. By splitting things up like this, you create a setup with no single point of failure. The part of the system that handles your payment, it knows someone paid, but it has no idea what they asked. And the part of the system that answers your question, It knows what was asked, but it has no earthly idea who asked it. No single party ever knows both who you are and what you said. So, with all that said, how does this actually stack up against other AI services that claim to be private? Let's take a look. This table really lays it all out pretty clearly. You can see ZK-LLM is unique because it uses math to protect your identity. Other guys like Venice or Proton, they still require an account. That's the old trust-based model. You see Nillion there, which uses another cool math approach, but it's just too slow for the big AI models right now. And of course, you could just run a model on your own machine for perfect privacy, but then you're stuck with much smaller, less powerful AIs. Let's actually zoom in on Venice AI for a second, because it's a perfect example of what makes ZK-LLM different. ZK-LLM actually uses Venice's fantastic TE hardware, that block box we talked about, to protect your prompts. That part's great. But with Venice, you have to create an account to use it. So ZK-LLM comes in and adds the missing piece of the puzzle, that ZK proof payment layer on top. You get the same awesome hardware protection, but with total mathematical anonymity. Look, I know this can all sound pretty technical and abstract, but it's so important to connect this technology to real people in real high-stakes situations. And that's a fair question, right? Is this whole thing overkill if you're just asking an AI for a good lasagna recipe? Maybe, but for some people, this level of privacy isn't just a nice to have, it's an absolute lifeline. And this is why it matters so much. We're talking about journalists who need to protect their sources, whistleblowers who are trying to expose wrongdoing, activists living under governments that watch their every move, or even lawyers dealing with privileged client information. For these people, leaving a digital trail isn't just an inconvenience, it can be incredibly dangerous. This quote just nails it. Think about it. If you're in a legal fight, the very questions you ask an AI could be subpoenaed and used against you as evidence of what you were thinking. With a system like ZK-LM, that record, that link between you and your question, it's not just hidden, it's not just encrypted, it literally, mathematically, does not exist. Okay, so as we start to wrap this up, let's just boil it all down to the single biggest takeaway from all of this. This is the big idea. We are right at the beginning of a massive shift in how we think about our privacy online. We're moving from a world where we cross our fingers and trust a company's legal team to a brand new world where we can check the math for ourselves. And that leaves us with one final thought to chew on. Once this technology is out there, once you have the ability to prove your privacy with Matt, should you ever settle for just a promise again? I'd love to know what you think.